This video is stemming from a recent call we got from an FTC coach, and they were asking about the different modes of the motors on the motor controllers and how to reset encoders. Now, first, we recommend that you don't necessarily reset your encoders because there's easier ways to do it in code that will take less processing, and that way you're also going to lessen your rounding error. So let's think back to that previous program where we ran to position -500 and then 500 and then -500 and then 500. If we reset our encoders every time, the encoders aren't actually getting to exactly the target. They may get to plus or minus 5 of the target, so they'll get to 504. And if we reset encoders, we're actually going to be 4 off from where we think we're going to be. So not resetting encoders and just keeping a target value is a better way to go for the most part. You can reset encoders to start with if you'd like, or as in the previous example, you can get a start position. Note that something we learned from this call is that run to position is the same thing as we say is run to position. Run using encoders is actually the same thing as run at constant speed. Run without encoders is the same thing as run at constant power. Just want to make that quick note. The user program that we saw was very similar to this. So they wanted to reset the encoders first, and then they also wanted to tell it that the motor was going to be in run to position mode. Now the mode is in the same register. So if we tell it to set the mode to this, what that's actually doing is it's taking that and putting it into a buffer to send to the robot. So it's going to be in your phone, and it's going to be waiting. The next time the phone talks to the controller, which isn't instantaneously, the next time it talks to the controller, then it'll tell it to set the mode to reset encoders. But the very next thing the user did was the user said run to position. So that's going to take this mode that it just put in the buffer, and it overwrote it with this mode. So now, next time it talks to the controller, which may not be until this wait for one full hardware cycle, the next time it gets there, it's only going to tell it to do this and not this, because this command was overwritten with this command before it talked to the controller. So to fix this, we're going to put a wait one full hardware cycle after this reset encoders to make sure that actually gets there. And then we can say run to position. The next time it talks to it, it will update the run to position, or that mode. Now we have the start position, so it should be 0. You can also check that. So you could go into an if and say, if start position does not equal 0, reset encoders and wait for a longer duration. Another thing that we can change from previous program to make this better is instead of having the set power and set target position before the wait for start, we're going to put that after the wait for start. And before, we actually only had a set power. We did not have a set target position. The only set target position we had in the previous video was actually down here. And that caused a problem. Maybe you discovered this, and if you did, I hope you're asking why. If your robot didn't quite get to that position, so let's say it was 6 encoder ticks away from where it was trying to get to, so it's busy, it's going into here, and then you stop the robot program, and then you run the program again, it's never actually updating this value because it's still busy, it's still trying to get to this encoder position that's 6 ticks away, so it's still going in here, and it's never updating this value. So we added another one of those before our while loop, but after wait for start, so then it'll update the start position at least once during the program, so then the motor will start to move. One more thing that you may want to change is that if your robot has inconsistent drag on the motor, inconsistent resistance, you may need to set a bigger range for the motor to get to. Right now, once the motor gets to plus or minus 5 encoder ticks, then it'll say that the motor is free. It got to where it needs to get to. But it won't always get there. Sometimes you get to 7 or 6, and it'll get there and it'll get stuck because the power is so low that the motor's not moving and it lost all this momentum. So if you stop it right before it gets to 5, it'll just sit there. So one thing you can do is say, instead of if motor is busy, you can set a target that's a little bit bigger, like 10 encoder ticks. And 10 encoder ticks is still really small, so that's very acceptable. So we can say the absolute value of, we're going to say where we want to get to, minus where we currently are, we're going to say if that is greater than 10. So now, if we are outside of plus or minus 10 of where we want to get to, then we're going to say that it's busy. If we are within 10, then we're going to say, well, we're close enough, because 10 encoder ticks is really small. And then we'll say it's free, and then change the target position and move on. Or if this was your autonomous mode, you would have a while loop and say, while it is outside of 10, then just wait and continue displaying app data. And then when it's not, then it'll move on to your program and go and do the next thing in your autonomous mode. So things get out of this. Run at constant power is equivalent to run without encoders. Run at constant speed is equivalent to the SDK's run using encoders. And run to position is run to position. If you want to reset your encoders, you don't need to. You can have a integer that keeps that, and we recommend don't do it more than once during a program, because having this variable tracked is a way to eliminate rounding error. But if you need to, be sure that you wait a full hardware cycle after you reset encoders before you update your mode. And if you want to set a bigger target, a bigger acceptable target that's bigger than plus or minus 5 encoder ticks, then you can say, instead of if busy, you can say if the difference between where you are and where you want to go is more than 10, then you'll be busy. Otherwise, you'll move on to the next thing in your program.